MedBix Webcast is a new kind of healthcare media channel to break the silo mentality and foster interdisciplinary thinking. Our mission is to fill that gap and to create a curiosity through different lenses, tapping the passion that guided the historical figures in medicine and bringing present-day groundbreaking research to the front lines. We interview physicians and leaders in the industry about present-day healthcare challenges on our live programming. Welcome to the MedBix Webcast. This is Raman Annamaraju. I'm the host. No, I'm not Albert Einstein. Maybe my guest is. So we check it out. So, one other thing is I want to talk with you a couple of things. I saw last night a movie called on Amazon Prime. I saw a movie called A Million Miles Away. It is a really great movie. It's just a heartwarming movie. It's a journey from a Mexican migrant farm worker becoming an astronaut. This is suggested by another physician, astronaut, Dr. Scott Brzezinski. Thank you, sir. Welcome being my part of my network. Thank you, sir. The Dr. Scott Brzezinski wrote some piece about it, and I saw the movie last night. It's an amazing movie. You must watch it. It's my family background is similar background, and when I was in India, southern India, economically tough situation, a small village, and then we have a non-existent healthcare system. No electricity, no running water. So I grew up in that kind of a atmosphere, so I can relate to that their journey. But my brother was one of the guys. He started that kind of journey, and he became a nuclear engineer, and he was passed away recently. But that is a million miles away. The watch on Amazon is a great example. I can show you this. That's actually if you see that, I want to show you. This is A Million Miles Away. That's a movie. Actually, I interviewed an astronaut from Canada, Shauna Pandya. Tomorrow, the program is that you could watch it. Actually, the astronaut that is space medicine. She was talking about space medicine and other stuff. So it is a great. So without further ado, let me introduce you my guest, Dr. Arnold Lee. He has a very interesting background. He went to school in Ireland, Catholic side. Then he came back to Harlem, a Baptist kind of a background. So he has a very contrasting education in a residency program he did. And then after that, he has a Python. He's also urgent care. I didn't know that there's maybe recently did that urgent care, board certified in urgent care. He's a physician, emergency care, ER physician. Then he is also certified in Python programming, So then he is an interesting. Let me bring a Dr. Arnold Lee back into the stage. Welcome, Dr. Lee.
How you doing? Nice to be here, Ramana. Thank you very much for the kind words.
So tell us a little bit about your background, personal background. Where do you stay?
Yeah.
What do you did so far?
So I've been in San Francisco over the last over 10 years. I initially worked at One Medical. After having done my residency in New York City, I moved to Northern California, then moved down to San Francisco in around 2008, 2007, where I was one of the first few physicians at One Medical. Was privileged to be part of the early team and saw it go from where it was to where it is today. I left One Medical in 2015 and moved into data science with a company that's since acquired called Lumiata. Spent a couple of years there and decided to move into different things. I transitioned from clinical care because I wanted to do things at a much higher level from a population health perspective. That's why I wanted to see what was under the hood. So I was privileged to be part of that data science company that gave me an opportunity to move into the back end or the under the hood side of healthcare. And I was also fortunate to be part of venture capital funds where I was given an opportunity to be an analyst at a Series A fund. I was also helping with a smaller pre-seed to seed angel fund, which I still advise today as an investor, and it's more like an investment advisor, also part of the investment team. I source deals. I give my due diligence and give clinical opinion as to whether solutions in the digital health space are going to be applicable and investable. So that's what I do. I was most recently at Komodo Health, and where I did some bigger data work. So Komodo is a slightly different version of Lumiata, a much larger version. And then I decided to start my own AI for healthcare consulting agency recently. Small little agency looking to help startups and small healthcare systems understand what is a solution they may actually need, right? I mean, it's like not everybody needs an LLM. You may need something simpler. You may need, like we had discussed earlier, some logistical solutions versus, actually fancy stuff. So there you go.
So you live in a epicenter of technology, so
Hmm.
that you deal with the technology side, and you're a physician.
Hmm.
So what is the usual mistakes the technology people come to you, and then one of the usual mistakes they do is they want to do healthcare startup, but they do some mistakes, that, and vice versa. A lot of physicians want to start the healthcare startup. They do certain mistakes in technology side. What are those intricacies of that, the interplay dynamics about the problems both face?
I guess it stems from an over eagerness to solve a problem from the technology side,
Yeah.
because it's like one thing I've learned is like engineers love to solve problems, and it's important to solve, to want to solve a problem, to have the motivation, but it's also very important to know how to solve it. And I think um, there needs to be more collaboration, like we had discussed earlier, between clinicians and technologists. Technologists and clinicians need to talk to each other to figure out what is your pain point, what do you need solved, versus trying to build a solution that may actually never ever get a client, customer, or any kind of adoption, right? If you think about it, there are some great solutions out there on paper, but when it comes down to like, how are you going to pay for this? Who's the client? Who's the customer? It's never really thought through. And unfortunately, that's going to kill a startup before it even really gets off the ground, because there are lots of nuances in healthcare, lots of regulation, lots of caution, lots of like people that are always concerned about deploying something new before it's thoroughly tested, and rightly so, right? And more importantly, it's like, if you're deploying a software solution, is it clinical decision support? Is it predictive? These are things that need to be thought through and need to be like, you know, discussed with stakeholders, trying to do before actually building something. And I think the analogy I gave you is like, this is a terrible analogy, and this is purely my opinion. And so you're not going to get a plumber to come solve an electrician's problem, right? Unless you talk to the electrician to figure out, can we work together? So that allows me to segue into the whole clinical side, right? So I'd say maybe the engineers are the plumbers, the electricians are the doctors, right? Doctors are great people. They try and help people by, with their approach to healthcare. But the thing is, like, it's it's understanding the business of technology too. Even if you want to deploy a solution that you've come up with, you have to understand the business perspective and what is the ability from a technological standpoint to scale that technology. I may have a great idea, but if it's technologically not scalable and it's not really going to answer a business question, I don't think it's ever going to be adopted either.
You're
So
talking about physician point of
yeah,
view.
physicians, exactly. So like I said, I was segueing into the clinician side. So from the engineering side, with that little analogy, and now I'm segueing
Scalability.
exactly. So I think the way forward is essentially, it's like, we have to put aside differences and say, let's sit down, let's talk to each other. There was a great actually event that was pre-pandemic that I used to go to, called Docs and Hackers, right? It was a great event that was hosted by a clinician and an engineer, right? And they used to bring people together, engineers and clinicians, to sit down and talk to each other. And it was like an engineer looking for a clinician to partner for their startup, and a clinician looking for engineers to help solve their problem. So I don't know if it's still happening. I hope it starts up again, but I think it was a fantastic event because I used to go to most of them. And that's where I met people, understood solutions, and became more entrepreneurial in my mindset about how we can actually work together to solve, you know, healthcare issues.
It's very funny, even though Stanford is next to you and the technology center is the biggest, Google is next, still
Hmm.
they're two different islands. They could not solve the healthcare problems a lot of times,
Healthcare is
and
tough.
they go parallel paths. Very
Healthcare is
interesting.
tough.
So I want to ask you another one is AI. There is a lot of buzz going on in AI right
Hmm.
now.
Hmm.
Everybody's talking about Chat GPT and all the
Hmm.
Hippocrates
Hmm.
AI and all these.
Hmm.
So what do you think of your idea? What is your view on AI, and how can we implement in the healthcare in a short term and a long term both?
Yeah, and I think I kind of want to take a quote from a doctor I listened to, Dr. Ziad Obermeyer, on the AI Grand Rounds podcast. I'm sorry, I'm shamelessly plugging them because I think that's a very good podcast that I think everybody should listen to, in addition to yours, because what they're doing is they're talking about, they're listening to key opinion leaders about what's out there, who's going to succeed, and so on and so forth. AI has its limitations. I mean, in terms of like, does everybody need an LLM? I don't think so, to be honest with you. And like we had discussed early on, I think AI can be leveraged to solve very specific problems very well. A hospital system may need a logistical solution, right? An AI driven logistical solution to determine, medication, to reduce medication waste, to predict how much orders and how much ordering of certain things that they need, like even simple things like bandages, supply systems. Right, that way it's kind of like you could potentially reduce hospital costs and so on and so forth. A really good friend of mine says that maybe it's a simple, classification algorithm, like where the appropriate email goes to the doctor, the inappropriate stuff doesn't go to them, it gets triaged somewhere else. So these are what they call, I won't say simple. These are not. I hesitate to use the word, but it's kind of like, they're not those moonshot solutions. They're simple, and not simple, but they're things that people need. And I want to kind of quote someone from Baptist Health in Florida. He actually said something at a VentureBeat conference recently that really resonated with me. Build your AI solution for your customer, your client. Figure out what they need, and go build that, because hospital CEOs, C-suites are constantly being, hammered by startups. I have this amazing LLM, this AI solution, but it's kind of like nobody's really asking the internal stakeholders, what do you really need? Ask logistics, ask pharmacy, ask anybody within the hospital, what is your dream shot? What do you want to see for the hospital system? And maybe everybody gets together and decides, okay, this is the most cost-effective solution that's going to have the most bang for our buck. It's going to help our system, and so on and so forth. So it's got to be a solution that's suited for the need, not a want, right? So that's kind of how I think AI can benefit hospital systems. It can, to a certain extent, help with scheduling, missed visits. Those things are very important because it's if you have proper algorithms that can also figure out who's the best doctor for this person's needs, like a matching algorithm. Why not have that, right? It's like right now you go on a site, you randomly select somebody from, again, this is just a thought, from a website. I think this person's going to be a good fit for me, but it turns out maybe that person's not a good fit. Maybe you can have a better kind of like algo that says, or model that says, I think this would be a better person for you. Like, I think to give credit to the, I could say, I'm reluctant to endorse them, but Match.com or, Hinge, any of those, dating apps have done a pretty good job, right? If you think about it. Why can't we leverage stat technology and put that in healthcare to match clinicians to, the patient, to the patient needs and stuff like that? So in some ways, it's also, there's a downstream effect of improved patient satisfaction, right? Better outcomes and so on and so forth. So again, these are just moonshots in my head about
No,
how
no,
we can
no.
solve these things. Yeah.
That actually, that algorithm, Match.com algorithm is run by,
Mhm.
is called a very powerful algorithm. It's called a stable
Exactly.
marriage problem. It is
Hmm.
actually won the Nobel Prize by
Right.
They won the Nobel Prize algorithm.
Right.
So it is a very powerful, that kind of
Hmm.
things. We got to use it to matching the resources and
Right.
the people
Right.
and the needs. You're absolutely right about that.
Right. And you can adapt it to vendors, right? Vendors for hospital systems. That's kind of like,
Absolutely.
it's the algo is in many ways agnostic of the data you feed in. With a little bit of modification, you try and figure out what's the data I'm going to put in here. How am I going to maybe train another model on top of that model and stuff like that? So again, these are just thoughts I have. Why not do this, right? There's great opportunity in healthcare. The question is like, do you want to do the moonshot stuff. So that's what I'm trying to say.
Yeah. Dr. Lee, you're a physician, you understand a lot of people right now, the physicians are going through a kind of a burnout situation there.
Mm-hmm.
There's a technology burnout, there's a EMO documentation burnout, or you can classify a million ways. But it is real. This technology is taxing on them quite a bit. How can we, with this burnout situation, is it AI is going to help them, or is going to add more problems or more taxing on them? What do you think of it?
And again, this is purely my opinion, just to put that out there. It's a double-edged sword, right? A lot of clinicians feel that technology is in many ways burning them out because it's kind of like, what is the solution really going to help me do? Is it really going to save me time? Is it really going to give me back my pajama time? It's got to be something that's really going to help someone get back the time that they need and really say that they're going to spend time with a patient versus, you know, typing into a computer. It's like, you're taking it's like, for example, if I'm engaged with you, you're not going to like it if I turn away and say, let me type out our conversation, right? It makes no sense. There's no eye contact. Healthcare is a human endeavor. Like Dr. Eric Topol says, it's important to have that
Yeah.
engagement. The thing about it is, like, even if you have an LLM that is ready to build a SOAP note for you, you're still putting in input, right? The question is, like, can that help? It could alleviate some of the problems. It might help some doctors feel better. It may not help the entire clinical, it may not help every clinician feel better about it, but if you can help a majority or some, it's better than doing nothing, right? So I think AI can help to a certain extent, but there are going to be limitations and so on and so forth. So we have to figure out where those limitations are, what roadblocks that we run into, and it's essentially adoption, right? It's like, what do you want to adopt? It's right now there's so many, deep scribe, Abridge, fantastic solutions out there, but is it right for your organization? Is it right for your clinicians and stuff like that? So we got to ask those questions. The double-edged sword to the whole thing is, like, for example, if an LLM is rolled out and patient and clinicians are now able to go see less patients but have better quality of life, the question is, like, will organizations, who have more interest in a bottom line, push for them to use the extra time to see, instead of 16 patients, oh, look, now you can see 30? That doesn't help either, right? So that's a double-edged sword, because the AI may actually help people feel better, less pajama time, assist them getting their notes out a lot faster, and I don't have to really work. Obviously, vetted notes, and they feel better about it. But then again, if you work as an employee, is that system going to make you see more patients? Oh, I see you complete your notes. You're done by 4 p.m. Now you can stay till 5. You can see another 5 or 6 more patients. That's what we want you to do. That is going to contribute to other issues, right?
That,
It's also, go ahead, sorry. Please.
go ahead, please.
Yeah. No, I was just saying that I think there's got to be a balance somewhere. The question is, like, how do we, and again, it's not just also for us for burnout. It's also, how can AI actually help the patient, right? It's also going to be like that communication issue. It's kind of like, we have a lot of chat bots, we have a lot of things, but it's like, there's a lot of information that's captured. The question is, like, how does that help the patient too? So is there patient burnout? Those
The,
are things that we got to
Yeah.
ask, right?
There is another problem, right? There's
Yeah,
a chat GPT or some other LLM model, large language models
yeah,
can create a false information, can give
yeah,
a false information. Then doctors are so busy
right, right,
invalidating the soul, that false
right.
information. It takes time for them to argue and prove that they're wrong. It's another problem that can create in the physician burnout side. Do you agree
Yeah,
with
yeah,
that?
exactly. To your point, it's kind of like, if there is some people don't like to use the word hallucination, or I would
Hallucination.
say maybe call it confabulation. I don't know. I mean, these are words that are, again, purely my opinion. Is that, you know in your haste to get something done, you may sign off on a note that's completely not, you know,
Yeah.
not correct, and then it may lead to other issues like legal issues and stuff like that. So there is the concern about also not just the burnout aspect, but the burnout aspect contributing to an over dependence on the output. Right?
Yeah.
You don't question it. You just go ahead and sign it off. It's not, the technology is not to the point, at least in my opinion, not as reliable yet to feel for me to say, yeah, I can safely say I'm going to completely 100% sign off. You got to be cautious. Like I think there's been some publications, like a good example is GitHub Copilot, right? GitHub Copilot accelerates a very, very experienced, seasoned programmer, right? But a newer programmer, a junior engineer, it slows them down. So the question is like, when you're a resident or you're a first year attending, what's your workload going to be like when you're using an AI tool for an LLM or something along those lines versus someone who's done cardiology or is a very experienced clinician like for 15 years and who loves technology, right?
Yes.
So it's
Yeah.
kind of like, who do you slow down, who do you accelerate, right?
Actually, you raised a very important point. That's library issue. So
Yeah.
you know that a lot of time these LLM models or these technology enterprise systems, they don't take any responsibilities, even though they produce the false information or they could go wrong. And only doctor is ultimately responsible. American Medical Association president is saying that we need to shift some of these risk and then blame to the technology producers. What do you think of that idea of moving that blame to the little bit to the towards IT system side?
I think my next point is going to be a little controversial in the sense that I believe the responsibility must be shouldered by all, especially for this. People argue that you don't blame X-ray machines. X-ray machines are a little different compared to artificial intelligence for healthcare and how large language models are trained. So you can't. I don't think you can really use that argument. And trust me on this, a very smart lawyer will find a way
Yeah.
to hook in and make an AI for healthcare company responsible. And then it leads to discovery, right? It leads to discovery
So
about how
you
to
are
train
saying
the
that they
model.
should be responsible a little bit. That's what you're
Well,
saying.
I think there's got to be some degree of that because you
Yeah,
can't.
yeah,
There's
absolutely, I
got to
agree
be
with
some
that.
degree of accountability because it's not like an MRI machine. It's not. It's not. You're using software that analyzes data versus a simple. I won't say an X-ray machine just as simply taking a picture. The X-ray machine deployed properly is going to pretty much take the picture you want, but there's no analysis, right? You're the one analyzing at the end of the day. The same thing with, like, for example, if you're generating a SOAP, a CDS tool using artificial intelligence to generate an output, there's some degree of analysis there, right?
Yes.
That's why the FDA has the CDRH, the Center for Digital Health and Digital and Radiological Health. They have you submit questions about, is my software a SAMD? Again, these are again purely my opinions, and I have lots of questions about what happens with regulation and stuff like that. I'm always really curious and interested about the space in that sense. So it's
Actually, yeah, go
yeah,
ahead,
sure.
please.
No, all I was saying is that all it's going to take is Romana is going to be a very smart lawyer to figure this out, and then that's going to be
Yeah,
issues.
but
Yeah,
there must be some legal framework has to be there.
sure. Some
So
say,
that,
yeah.
Dr. Lee, that when I come back, I will present a topic:
Mhm.
the physicians' contributions. Actually, we are the amount of the doctors. If you see the history of the physicians, you know what they did is amazing. So I'm going to present a small topic on the electricity and the physicians, what they
Mhm.
contributed, and then after that, you can jump in anytime, any comment, and then after
Sure.
that, I come back and ask you about your Celtic house and your
Yeah,
personal
sure.
business
Yeah,
enterprise. Let
sure.
me bring it to the both. We are going to watch together this one. Let me
Sure.
bring together.
You might have heard about a psychic squid
One,
that predicts world.
that's I put the wrong one. So let me put this and
Okay.
okay. So let me introduce you this. I'm going to put both of us together in the bottom. Maybe that
Mhm.
yeah. Just okay. So both of us are watching together. You can jump in anytime, Dr. Lee.
Mhm. Mhm.
This is about the 70. The story starts in 1762, and the physician is a doctor. Is a physicist. His name is Giovanni Aldini. He's an Italian. He was born in Bologna, Italy, and then he's a big, Bologna is a big educational center in Italy.
Mhm.
So he was one of the highly educated. He's a physician and a physicist together,
Mhm.
and then he spoke several languages: English, French, Spanish, Italian, of course. So
Mhm.
he is a well versed in the languages. So he is one of the story starts here. The physician that I'm going to talk about the story of the physician and
Mhm.
electricity. So actually, Dr. Alini learned a lot of these physics from his uncle Luigi Galvani. Luigi
Mhm.
Galvani he was experimenting a lot of these new things. What he was doing is he take the dead frogs and connecting the head and the toe and the leg of the frog and see that and they saw the twitching. Then he concluded there is a. He says that his uncle was saying that there is a life inside is coming out. There is a life force coming, resurrecting the life. That's a galvanism in 1700 is a big physics. If the people believe it or not, they thought they all believed there is a life inside is coming out, so resurrecting the life like Jesus coming back.
Mhm.
So, but that is a big problem in Italy because Dr. Aldini was skeptical about that, but he followed. He did a lot of he learned from his uncle Luigi Galvani. Galvanometer is actually we measure the electricity is named
Mhm.
after his uncle. So Dr. Aldini was kind of a learned from his uncle, but is skeptical about his conclusion there is a life inside. But he did a lot of work in the Dr. Aldini did a lot of work with the animals with electricity. He wrote a book called Animali Electricitati. It's an Italian book, very popular book at the time. Animali Electricitati is a bunch of the conclusions he made on the electricity, on the animals and how it work, and what is a but eventually he wanted to do on the humans. But in the Vatican, there's a problem in the Vatican because that's a you remember Catholic country is a Pope is there. Vatican said that no dead humans, you cannot touch any humans
Mhm.
in Italy. So he has a problem. He cannot do anything. So what he did was he was a Dr. Aldini moved to England where there is an exception. He moved to England, London. Actually, if London there is an exception. If a prisoner get executed by some problem, and then they can be donated. That can be done. You can do experiments on that body. You don't need a consent from the families or anything like that. So that was the exception. So he was waiting for a dead body to come. Somebody was
Interesting.
hanged or something. He was waiting for the dead body to come to his lab. So he set up a lab in the Newgate in London. Dr. Aldini moved to, he spoke English, you remember. So that he moved to London, he was waiting for a dead body to come in to experiment electricity with the dead body. That is exactly what happened in December 14th, the 1802, December 4th. There is his name is George Foster. He was a drunken state. He drowned his wife and a child in the Paddington Canal. So he was immediately, there was a quick trial, a very quick trial, and then he was sentenced to death by hanging. In January 4th, they were in January 18th, he was executed. And they say there is some lobbyist also. Aldini hired a British lobbyist to make it accelerated. Less than a month, he was executed. So within a month, he was executed. His body was transferred to the Dr. Aldini's lab. Dr. Aldini took the lab and he called all the surgeons in the Royal Society of Royal Surgeons, all of them. He made a big spectacle of the lab. He invited a lot of doctors to see how the electricity works with the body. He wanted to experiment and show people. He was doing actually illegally in Vatican in Italy. There's a lot of grave robbers giving the bodies, but he was doing in the Italy that in London he wanted to experiment with the electricity. That what he did was he got the first battery from Alejandro Volta, another Italian producer, the first battery. That's why voltage we call voltage. The word came from Alejandro Volta. Is a physicist from Italy. He was the one who invented the first battery. What he did was he put a bunch of metal plates. He put the metal plates and stacked up together. Put the salt cloth in between them, so then the chemical reaction produces the electricity in between them, connected to the wire, and they connected to the dead body, that wire. So what happened is when he connected the dead body with that voltage, it is squared, it is contorted, it stood up, it contorted. Sorry, my English is may not be perfect, but it's a shivering and all those things. It is a lot of people were shocked. Actually, the guy, the lobbyist who was watching this thing, he thought that there is a demon behind it and coming out of it, and he got a heart attack and died. So it's actually London Times published that particular cartoon, seeing that the demon is behind the a devil is behind this life when it's coming from the electricity. That's what the conclusion was. They didn't know that, but Aldini was a nurse that this electricity is playing a role, and that was the zombie kind of a thing that created through electricity. That was the genesis for actually after a few years Mary Shelley wrote a book on horror story, the Frankenstein, because her father was talking about the galvanism, the experimenting the bodies through electricity, through Dr. Aldini's experiments. Her father was talking with her about that incidents, that how the electricity working with these dead bodies is creating a kind of horror zombies. So she wrote a best runaway seller. The first copies are 500 copies. January 1st, 1818, she produced the first 500 copies. That was the best runaway seller. And then it put the generation of children into frightening mode. So that was her contribution to that is came from the experiments that done by Dr. Aldini on the human bodies. That is the inspiration for her, that for the book Frankenstein, the famous book. But that's why. So, what is electricity and magnetism? Electricity and magnetism are same force. Actually, Michael Faraday, just like a million miles, he was also he was a lab technician. Michael Faraday in England was a lab technician. They did not give him any credit, but he invented he discovered the electricity. So he discovered the electricity and magnetism. So he found out the magnetism and electricity are the same force. Electricity creates a magnetism. Magnetism creates electricity. These are interchangeable. They're a manifestation of the same force, electromagnetic force. So you take a coil and then you run electricity through it. It produces the perpendicular right thumb rule. It produces the magnetism in perpendicular rule. In the field is produced. Magnetic field is produced. You can do other way around. You can take a coil and go back and forth with the magnet. You can produce the current. With the galvanometer, you can check it. So the electricity and magnetism are mutually connected. They're one and the same electromagnetic force. That was a mathematical structure given by James Maxwell. Is a four mathematical equations, mathematical framework was given. These two giants of electricity and magnetism are the Michael Faraday and the James Maxwell, produced the electricity magnetism. They gave a practical, pragmatic, and a theoretical framework. They gave it to the both are physicists. They're very well respected in the physics field. So the first EKG was produced in a 600 pounds. First EKG was. It is a William Anethon is the Norwegian professor produced he created the first EKG machine. A lot of galvanometers, a lot of these things, because he won the Nobel Prize after he died in 1924. He won the Nobel Prize for that. But first EKG was produced 600 pounds. 5 people used to operate the EKG machine, sir. Think about that. So the another giant, people didn't know that. A lot of people think about Nikola Tesla is about the electricity, but he did something contribution to the medicine. He was the first discoverer of X-rays. He called shadowgraphs. He didn't know exactly those old functions of the X-ray, but he understood the shadowgraphs of the X-ray, the electromagnetic radiation. And then also he invented the dithermy kind of machine that electricity producing the heat and a deep muscle. You can do physical therapy. The people use it nowadays. So this is the Nikola Tesla contributed quite a bit. He doesn't know, people don't know about the Nikola Tesla contribution to medicine. It was quite extensive. So as you know, the heart and brain, the work of our body works through electricity, the electrons moving them back and forth. The heart produces electricity. It actually takes the electricity and moves the lub-dub movement, for the SNO. That's people that all the doctors know about it. Engineers know about it. This electricity is the one who does that. That's why pacemakers, and if that misstep, we introduce pacemakers or defibrillators that we use to produce that, reinvigorate that process. But heart and the brain produce. Brain is a 10-watt electric bulb, actual electricity, electric thing. You can put 10-watt electric bulb. We can do that. Basically, that's what it is. So both of them produce the electricity. We know how to measure it. In fact, we have everybody knows, all the physicians know, and the EEG, electrocardiogram, you can measure the QRS complex. That's where the ST depression, you can measure quite a bit of information, you can get it. So that is a very useful in the EKG, heart rate variability. We use it for preventive measures, basically. So EKG is extremely, the electricity is the one playing role. So measuring electricity of the human body, we are doing that now. The brain, you do EEG, electroencephalograph, that you can do seizures, detection of seizures, dementia, and all the things. It's what is the short circuit in the brain. You can figure it out through the EEGs. That's what we use. Two very popular diagnostic testing. A lot of doctors know about it. But so there is a big now. Actually, I work for a company now. So there's a patch. You can just use a patch. Think about it coming from a 600 pound to a few ounces. Now the patch you can throw away a patch. It can transmit the entire EKG system to the cloud right now. So EKG is such a, we came a long way in 300, 400 years from there, so we came a long way. So EEG now, there is a company called Zito. They produce electroencephalograph. You don't need a glue and the wires, it's a basically wireless. Just you plug in. You don't need to measure anything. You just plug in. You can do EEGs right on the spot within 5 minutes. So these are the companies in Silicon Valley, based in Silicon Valley. So we are quite familiar with electricity. But what about the magnetic field? We don't know anything about much magnetic field. How do you measure the magnetic field? Because wherever there is electricity, there is a magnetism, right? So why we are not measuring magnetic field? That is a question that is because the magnetism is very tough to measure, because if you understand the magnetism and if you can measure it, the spatial and the temporal resolution is out of this world. You can pinpoint in the heart, because the heart attacks or congestive heart failure is much more complex. You can figure out exactly what part of the cells of the heart is damaged, and then also in the brain, what part of the epilepsy, what cells are causing the epilepsy. You can pinpoint, you can remove them. So, but that magnetic field, because Earth as a magnet, Earth itself is a magnet. So it has a huge magnetic field. It overshadows all the magnetic fields around it. So, but we are clever. Humans are really endeavor. We are finding way to measuring the magnetic field. I'm going to play a quick video. You can watch it and then say, let me play that video, guys. So this is a
dinner, or at least you have seen at the dinner table. The squid I am talking about is neither. This squid accidentally fell on us 100 years ahead of its time. The squid contribution to the medical field is invaluable. It revolutionizes the way you predict and diagnose diseases. This squid hunts cancer cells like you've never seen before. It will pick up source of seizures in the brain like no other. It is just not picking the needle from a haystack. It can pick your lost nail from the Appalachian Mountains. Hello, my name is Ramana Anamaraju. I have a passion for physics, specialized in allied healthcare, and above all, concerned for well-being of all humanity. Edward Flynn was hit by tragedy twice and lost both of his wives to breast cancer. When his first wife fell in coma, he used to visit her at the hospital. He used to whisper in her ears, wondering she may be understanding what he was saying. After a few months, she died. Not knowing his wife understood his undying love for her or not is frustrating. Then second wife, after a brief marriage, lost to breast cancer again. He is determined to do something about it. Edward Flynn is neither king nor can afford to build a Taj Mahal in memory of his beloved wives. But he built something better. He built SQUID. Acronym for SQUID is Superconducting Quantum Interference Device. As strange as that name is, This device is out of this world. He brought a mystical and elusive quantum nature of our universe to the benefit of the world of humanity. Edward Flynn is a nuclear physicist at the prestigious Los Alamos Defense Laboratories. He gave a remarkable gift from mother of all sciences, physics, to the field of medicine. A new machine, magnetoencephalograph, was born, usually referred as a MEG scanner. This exotic hair blower looking machine is a mag helmet made up of several squids, which are quantum devices that are designed by Edward Flynn's team. This machine, without touching the body, can read magnetic fields coming from a body that are 100 million times weaker than our Earth's magnetic field. Amanda Malmsberg of Wisconsin fell on the kitchen at the age of 8 with a first epileptic seizure. She was getting seizures almost 100 times a day by the age 16. With the help of neuroradiologist Dr. Deepak Raghavan, they made a journey deep into her brain by using MEG scanner.
MEG, or magnetoencephalography, is a relatively new tool that's become available to us, which is capable of looking at the magnetic fields generated by the brain and localizing them back on the anatomy of the brain. At this time, Fredericton Medical College of Wisconsin is the only center in Wisconsin which has a clinical MEG program. We do see patients from not only our hospital but other centers as well. Most people are familiar with electroencephalography, or what we call EEG, where you record brain activity or brain waves from electrodes that are planted on the scalp. Now, there is a substantial amount of tissue and fluid that separates the generators of that electrical activity in the brain and the locations at which we are recording this electrical activity, including tissues such as the skull and scalp. So that can substantially alter the view of what we are looking at in the brain, pretty much in the same way that if you're trying to listen to a conversation through a thick wall, you hear muffled sounds. You may vaguely be able to place people in different parts of the room, but not quite clearly see who spoke from where. So alternative techniques which are not affected by the tissue is of great interest.
Without single incision looking for the elusive source of epilepsy, it is just like looking for a needle in the Grand Canyon. It is that difficult. They found the source of her problem hiding deep inside of her brain. No other modality, including powerful MRI, even come close to these findings. The very tiny source of area that is causing her seizures was surgically removed, and Amanda is living happily ever after without even a single incident of seizure. The woman's life was given back by this remarkable machine. The researchers racing towards to find that very tiny number of cells that causing Alzheimer's, schizophrenia, depression, autism, and chronic alcoholism, and many other brain-related diseases. MEG scanner is taking on the most challenging and the deadliest disease of all for women, breast cancer. With the present technologies, you need 10 million cells to be affected before it shows up on any modality or device like a mammography or MRI. But the MEG scanner hunts for those few thousand cells causing cancer out of 90 trillion cells, not a billion, 90 trillion cells. Probably MEG scanner can detect breast cancer 5 to 10 years in advance before any modality. Vanderbilt Gastrointestinal Squid Technology GIST Laboratory is an interdisciplinary initiative by the Department of Surgery and by the Department of Physics to detect how to find stomach ailments. Can go on. This is a direct demonstration of quantum physics in action through a medical device while saving countless lives. Nuclear physicist Edward Flynn may not have saved his wife's life, but saved countless lives on her memory and will be saving millions in the future. It is better than a Taj Mahal indeed. Thank you for listening.
So that is the power of the electricity and magnetism. The magnetic side of the story is a very new, and that's what I was telling you, that eventually we are catching up on that one. So the next part is that squid is a super quantum, I gave you the magnetoencephalograph machine. You saw that already. So these are the giants. Newton said that I'm standing on the Newton himself is a giant in himself, but he said that standing on the shoulders of giants. People like Aldini, Giovanni Aldini, a doctor who moved from Italy to England and experimented bodies on the electricity, and then Luigi Galvani, his uncle, who was doing experiments with electricity and the life itself and the animals, and the Michael Faraday, a lab technician who produces the electricity, and the James Maxwell, who gave the mathematical framework for the electricity and magnetism, Nikola Tesla, who produces some of the electricity and alternative current for us, and he gave a greatest inventions for us. And then Jagadish Chandra Bose is another one, the Indian physicist, who gave a lot of semiconductors and the inventor of semiconductors, and he gave electricity in the plants actually invented, and the Benjamin Franklin, who did a lot of work on the lightning and the glasses. So I think these are the greatest scientists that the electricity and magnetism created. All these experiments came on. Thank you for watching, and I thank you for watching. And let me bring back Dr. Um, Lee back to the stage. What do you think, Dr. Lee?
Very interesting. Learned a lot more about the history of medicine and physics today. So thank you very much for presenting that. Appreciate that.
Thank you. Yeah, it is doctors like you do a lot of behind the scenes, and I think my daughter went to technology side, and my son is in medical. He's in neuroscience. One day my daughter told me, Dad, this is a hard. The science is biology, sciences, and it's so hard. 10 times harder than all of our subjects. Don't believe anybody says that. The IT is just medicine is extremely hard, and it took me a long time to even understand the basics. So I tell you, it is a very, very hard. So I really admire all of you in the physician community. That's why it's a physician advocacy channel. So tell us a little bit what you do besides Dr. Lee, besides all these. You completely gave up medicine, and then you're doing a lot of entrepreneurial work. What kind of companies you're involved right now?
Yeah, so essentially, I moved away to a different track. I felt that I wanted to pursue a different career path. So I was fortunate to be involved in the VC world, like I mentioned before. I'm currently an advisor that conducts diligence, helps with the investments for a small pre-C2C digital health focused fund called Celtic House Asia Partners Health. I mean, it's part of the larger fund. It's a larger fund is more of a generalist fund, and we have like specialist sub funds, which is what Celtic Health, Chap Health is. So we are actually focused on solutions that are going to be impactful, that have data in the digital realm. We've done quite a few. I mean, I'd love to talk about them, but it's like, we're in a public forum, so it's kind of like I'd like to keep that a little more private. But essentially, it's a very expertly curated team with a clinician like myself who's got a bit of machine learning AI experience, a clinician that actually has consumer experience, a friend of mine who's also been in the regulatory space now, GP, who's comes from a finance background, but has a great understanding and willingness to learn about the health space. So it's a good team, and it's kind of like it's been a very good experience for me. I've learned a lot seeing the beginning to the end, and that's kind of like the end side is where I did an analyst position in a Series A fund where we did digital health too, seeing different solutions. Going from like the really early stages, focusing on the teams, understanding their vision, the passion, and that special combination that makes a startup succeed, to seeing the growth stage at a Series A, right, where there's some traction, that you're moving higher up. You're kind of like at a certain inflection point. You need more money to kind of grow even further and faster. You're doing different things. So I kind of saw the gamut of like point A to, I'd say, point B and stuff like that. So that's kind of like what I do mostly on a daily basis. But again, I mentioned before, I started my own AI for healthcare consulting company called AI Med MD. Part of the reason is like I also feel like startups and small little hospital systems need some guidance. Like I said, I'm not by no means an expert, but I do try to leverage what I've learned in both machine learning, artificial intelligence, and healthcare clinical workflow and venture capital experience, the venture capital space, to help people determine, what is going to be the right solution for them, right? It's kind of like a lot of people want to understand how to get the best bang for their buck. If I'm going to either, deploy an AI solution, what am I going to do? What am I looking for? And this ties back to what I had mentioned before about it could be a simple solution. Like I said, not everybody needs an LLM. So that's the kind of goal that I have. I also, it's just, I think it's ripe. It's the best time to be in California because of the way AI is becoming very focused on by the recent push by the governor to make California a center for AI. But it's also a right time for us clinicians or former clinicians to participate in the process, right? We have to have a seat at the table, and that's why I decided to do what I wanted to do, because I think as somebody who's had clinical workflow and still maintains good relationships with my clinical colleagues who still practice every day, I'm sort of bridging the gap, right? I'm talking to technologists, but I'm also talking to my colleagues, my former clinical colleagues, that, hey, do you think this is something that you would want to see? It's also being able to talk to the engineering side, the technology side, and the clinician side is very helpful, right? Because sometimes we all have to get together, like I said, and talk about this sort of stuff. So that's what I do.
What is your website or email that the people want to read?
Yeah, my email is arnold@aimedmd.solutions.
Arnold, what is that? Arnold?
I'll put it in the chat. Give me 1 second.
Yeah.
I'm in the process of building the website. I mean, it's been a little. I've been really busy, so I do know I need to sit down and decide.
You can edit your name itself there, right there. It shows up right there on your screen. If you can
I'm
go
doing
the,
right now for
the
you.
screen and
So,
the editing. Yeah.
there you go. I put it in the chat, and then
Okay.
yeah. So anybody can reach me there if they're interested in discussing consulting and stuff like that. Again, with the services that we offer is we potentially connect them with other solutions and other companies. They may be able to help them, right? It's not just about helping them develop strategy, but also helping them find solutions. Like maybe this company could help you, build something that you're looking to do, right? There are startups that do federated learning, for example, right? And that could be really helpful in the clinical research space. If a site wants to be a clinical research trial site, and then but they're reluctant to they're concerned about data leakage and stuff like that, they can use a federated learning model and so on and so forth. I mean, there's a lot of options, and again, with a lot of people that I've continued to work with, there's ways to solve problems. Some may be harder, some may not be harder, but there's always a way through.
So that's Arnold at AIMD.solutions.
Yeah.
That is your email address.
Yeah.
There's a lot of people, the early stage companies are a struggle. There is a lot of noise. If you even provide a good solution, this noise eats everybody out, and the good people get disenchanted by this whole process.
Right.
And then they don't. I'm one of them actually in the beginning stages. Well, they don't. It is so much noise there. IT industry have such a noise they make it,
right.
And the people who want to provide a real solutions, they're just overshadowed by these people.
Yeah, and it becomes an issue because, to your point, right, when you have so much noise, you're trying to figure out who really has the right solution, and it's every aspect of. I wouldn't say every aspect. I'd say you have to really want. Okay, let me rephrase that. I want to say is what I want to say is that sorting through the noise essentially takes time. It's not going to be that easy.
It's not easy at all.
It's kind of like, and that ties in back to what problem are you trying to solve? Yes. If you understand what problem you're trying to solve, and you're fairly certain that this is a real true pain point, and this is where the technologists and the doctors can come together, it's going to be like, okay, now I have an idea of what I want to do. I think this is I found out this is a pain point. 99% sure about this. I've done the market research, everything that I've done. I've checked with a lot of people. I've figured out what the issues are. Talked to the relevant stakeholders, let's say in a hospital system, right? Now, I can go through this noise and cut away.
It's not easy that goes.
Yeah, it helps. But it's still gonna it probably will get you, I'd say maybe 50% of the way. Yeah. And then after that, you got to start thinking, you got to start iterating a little further down the line. And you got to figure out that 50% that you've cut, Now you got 50% left, and you cut it down even further, right? It all comes from experience, and sometimes you fall, and you got to pick yourself up.
A little
That's
bit of luck
essential.
also involved.
Yeah, a little bit of luck. I mean, so you never know who you're going to run into. It's like sometimes LinkedIn is great for, cold conversations. You never know you're going to meet, and sometimes it just doesn't work, right? So it's the same concept, right? It's kind of like iterating through the whole process and to
Great
iterating through the
wisdom, Dr.
noise.
Lee. A great wisdom, Dr. Lee. Thank you so much for joining with us. It is a truly an honor and privilege for me to talk with you. It is educational for all of us. It is particularly in the center of Silicon Valley. We are experienced. We saw everything in there, what goes on, in particularly in healthcare in the Silicon Valley. Thank you so much for joining for us.
Thank you, Ramon. I really appreciate your time, and thank you for having me on the podcast. Great conversation. Thank
You
you
could
very
stay
much.
for a
Take
few
care.
more minutes. I'll talk with you after the broadcast. Just
Sure.
let me play with this one. And thank you all for joining. Good night, all of you.
We are retelling their stories through our patented designs that can be worn on scrubs, t-shirts, printed on conference bags, and endless other promotional materials. Daily Wear for Medicine is the first ever of its kind to create curiosity in medicine through visual art. We at MedBricks are celebrating unsung heroes of the past who made enormous contributions to the field of medicine through our unique campaign called Daily Wear for Medicine. You can wear it, carry it, and give it.